Are you concerned about sensitive data lingering in memory? You're not alone. Today, we're diving into the importance of cleaning up stack contents, especially when it comes to handling sensitive information like card numbers. I totally get it. With PCI, with PADSS certification requirements, ensuring that sensitive data doesn't end up where it shouldn't is crucial. It's a common concern for many developers and security professionals. Here's the specific question we're addressing. One user asked, is it necessary to clean up stack contents? They are worried about memory contents being written to the page file and how to handle sensitive data safely. Sound familiar? Let's explore this together. So why is this important? When an application runs, sensitive information can remain in memory even after it's no longer needed. If the operating system swaps memory to disk, that data could be exposed. Let's break down the situations we need to handle. And stick around. At the end, I'll share a powerful tip on how to ensure your application handles sensitive data securely. To begin addressing the user's concern about cleaning up sensitive data in memory, the first step is to handle heap allocations. Before freeing any allocated memory, the user should use the function memset to clear the memory area. Next, the user should focus on static or global data. After using this data, it is crucial to clean it up as well. Again, memset can be employed to ensure that sensitive information is removed. Now, let's discuss local data, which is stored on the stack. While local variables are not accessible after the function ends, the user should still consider zeroing them out before the function exits to enhance security. Finally, the user might wonder if there's a way to clean up the stack memory before the program finishes. Unfortunately, there is no direct method to clear the stack, but ensuring all local variables are zeroed out at the end of their respective functions is a good practice. For example, consider this code snippet. In the function test, we have a character array for the card number. After the function executes, the memory still contains the card number information. We can use memset to clear it. Fun fact, did you know that the first computer virus was created in 1986? Just like that virus, sensitive data can linger if not properly handled. Let's make sure we don't let that happen. Now let's look at the answers provided by other users. This user suggests that cleaning the stack at the end of the program may be too late, as sensitive data could have already been swapped out during runtime. Instead, they recommend using virtual lock to keep sensitive data in memory, preventing it from being swapped. However, there's a limit to how much memory can be locked, so it's best to avoid storing sensitive data on the stack altogether. That's it for that answer. Let's take a look at another one. This user suggests a different approach to cleaning up sensitive data from memory. They demonstrate how to use a class to manage the card number securely. When the class is destroyed, it uses a special function to clear the memory, ensuring that sensitive information is not left behind. The user emphasizes that the stack memory will not be cleaned automatically, so it's crucial to implement your own cleanup methods to protect sensitive information. That wraps up that answer. Let's move on to another one. This user believes that cleaning up stack contents is necessary, but highlights that it's only part of the solution. They point out two main issues. First, the operating system can swap data while it's still in use, so using commands like virtual lock on Windows or mlock on Linux is important. Second, they emphasize the need to prevent the optimizer from removing the memset function, which can be addressed by using secure wipe buffer from CryptoPP. They recommend avoiding manual cleanup due to its error-prone nature and suggest using a custom allocator or class template for secure data management. Let's take a moment to review another user's answer. This user explains that the stack is cleaned by moving the stack pointer rather than popping values off it. They emphasize that you need to handle this manually as the compiler manages the stack. Additionally, using the volatile keyword can prevent optimizations for specific variables. They also mention that while you can manually pop the stack clean, it requires assembly language, which can be complex. Here's the tip I promised. Always implement memory cleanup routines in your applications. This simple habit can save you from potential data breaches and keep your users safe. And there you have it. By following these steps, you can ensure that sensitive data is properly handled in your applications. If you found this video helpful, please subscribe for more tips on secure coding practices.